So you need to get good at recognizing things. When you see this, when you look at this, what does this almost look like? And when I say this, I mean, what does if this actually goes, come on. What does this right here look like? The 3 over n, what does that almost look like? Which is what? What would that, it almost looks like 1 over x squared. That's correct, but that's, if we want to run the integral I love this. There's 2 different directions you can go in this question. There's like a super quick way, and then there's the way they wanted you to do it. So let's do the arctangent method. This almost looks like, not arctangent, it looks like the derivative of arctangent, right? So you want to make it the derivative of arctangent so that you could then integrate it in one step. What can you factor out to the front easily, just right at the beginning? What can you turn this whole thing into? 3 times this summation, right? Are you allowed to do that? Yes. So what's the one term there that kind of makes you say, it's almost there? What's the one term? The plus 4. What do you want that to be? Plus 1, right? So what did you say? People up front were saying this. What should you do? Yeah, factor it out. Are you allowed to do that? Sure. We just tend to shy away from it because we don't want to induce the creation of fractions. Get over it. So what do you end up with? 3 over 4, the summation from n equals 0 to infinity of 1 over n squared over 4 plus what? 1. Well, that's kind of nice. How could we rewrite that? 3 over 4, the summation from n equals 0 to infinity of 1 over what squared? N over 2 squared plus 1. And then if we really wanted to make this perfectly in the form that we're looking for, what substitution could we make? What simple substitution? We could let w equal what? If we really wanted to here. What? You want to just n over 2? Sure. Absolutely. You could do that. Absolutely. Is everybody with me so far? So at this point, you could substitute, or you could set up the integral first. Let's set up the integral. It's 3 over 4 times the integral from this to this of what? 1 over n over 2 squared plus 1 dn. And I don't really like putting n in there, so I'm just going to make it x over 2 and make it what? Dx. And then let's do what Ethan suggested. Let's let w equal x over 2. So 2w is equal to x. So let's do some substitution here. Can we have an, quote, infinity as a limit of integration? No, it's the limit as, let's say, b goes to infinity, 0 to b of 1 over w squared plus 1, but we don't write dx. We can only have one variable. So if w equals 2x, what does that tell us? 2 dw is equal to what? Dx. You differentiate both sides. So when you substitute this in, what do you put right here? 2 dw. We now have one variable in our integral. We're okay. So we pull that 2 out, you end up with 3 over 2, the limit as b goes to infinity, 0 to b of 1 over w squared plus 1 dw. I'm going to stop right here. Is, in my opinion, to memorizing the derivative of inverse trig functions, they're all what? They're all really similar, right? It's really hard to memorize things that are all really, really similar. They have like square roots and stuff. You have to memorize them. Because here's the thing.